Now we jump to section 16.3. We are skipping 16.2. Analysis of a large problem. So when you have a lot of independent variables, then that would be a large problem. So when you have a lot of independent variables, the problem of multicollinearity is more likely to exist. So we have to analyze for that. We already talked about multicollinearity in the previous chapter. It is correlation between a pair of independent variables, and if a pair of independent variables correlation, the absolute value of the correlation is greater than 0.7, then that pair is said to be highly correlated, and therefore one of the two variables must be dropped from the analysis. And remember, this is only a thumb rule, so this is not something that one should follow as though it is a law. So let's look at an example of how to analyze for multicollinearity. So in this example, this is from your textbook, we are talking about total sales credited to a sales representative as the dependent variable, and then you have a bunch of independent variables. There are 8 of them. So length of employment, market potential, that is the total industry sales, advertising expenditure in the territory, market share weighted average of the past 4 years, change in market share over past 4 years, number of accounts assigned to the sales representative, a weighted index of annual purchases and concentrations of the accounts, and sales representatives overall rating on an 8 performance dimension. So these are all the variables that we have. Now the first step in handling large data set is to take a look at the independent variables, and is there any correlation that is too high. So let's go to the Excel sheet and take a look at that. Now when you open the shell file, you have to make sure that you enable content. If you don't enable content, the stepwise regression won't work. We're going to do that next. So make sure that you enable content. Now we have the data right here. So the definition of the variables, okay, let's copy this over here. So y is equal to sales and so on. Now the first step is to run a correlation table and then see what the correlations are like. So correlation is data analysis. You select correlation. Okay, so now we're going to include all the variables. We'll start the output from here. And now let's format this. And we can use conditional formatting to see which ones exceed 0.7, our thumb rule. Okay, we can go to conditional formatting. So greater than. Okay, so we'll use 0.7. Okay, that only looks at the positive side, so you have to do another conditional formatting. So this time is less than minus 0.7. Okay, so that gives us 2 correlations that are greater than 0.75. The first one is with y. So this first column is correlation of all the independent variables with y. These are good correlations. So this is a good one. What we have a problem with is this. The account is highly correlated with time. So there is a multicollinearity problem between these two, and one of them must be dropped. So either accounts must be dropped or time must be dropped. And it looks like accounts is more highly correlated with y than time, so maybe time is what we need to drop, which is what we will do. accounts and time are highly correlated, so one of them must be dropped, and we will drop time because time has a smaller correlation with Y compared to accounts. So we will drop that. So in the next step, we're going to build model with sales and the remaining variables. So variables for model building then is, so let's copy all of that. Okay, but not this. This is not going to be included. The remaining will be included in the model building.